I see people are still logging in, so we'll give it a little bit longer. But I do want to introduce the session today is, like I said, multimodal pipelines, which is very cool. Our speaker today is Sam. Sam is a seasoned technology leader with over 18 years of experience. I've worked with Sam at Hortonworks or Cloudera, whichever it was called at the time. He's a real expert in a lot of technologies around data engineering, analytics, and AI. And he is currently the CTO at Datavalo, and he's in charge of the field engineering team, which is pretty awesome. He comes from Google and Databricks and Hortonworks and a lot of cool companies. So if you're ready, I think the number of attendees is stabilized. Welcome, Sam. Kick it off.
Thank you, Tim. Great to be here. Very grateful for Zillis having us on the webinar today. Thank you for the kind introduction. So Tim and I have worked together in the data engineering space at Hortonworks, and very excited to be collaborating again. So today I really wanted to talk about the day two moment for adoption of AI applications and what that implies for the data platform, the data engineering, and the overall AI stack that enterprises need to be successful. So I'm going to start with some observations around the state of the AI market with a lens on the data set of challenges. And then I'm going to show you a bit of a demo. I have two different demos if we get to both. We're going to show the Datavalo platform, and we're going to take on what's kind of become the hello world of RAG, which is processing of financial 10K documents so that I can get the right data that I need for a kind of chat with my docs as a financial analyst style of use case. So looking forward to having questions towards the end as well. Happy to set aside a good amount of time for Q&A. All right, let me share my screen here, and I'm going to jump into some observations that I've had, working with a lot of enterprises over the past several years. As Tim mentioned, I spent about 4 years at Google Cloud. I was helping digital natives like Datadog and MongoDB and Colibra build data architecture and adopt language models like Gemini, I think Palm at the time. And one of the big challenges I saw was that folks were not spending enough time thinking about the disruption for the data tools that we need to make AI apps successful, and that there needed to be more of a recognition that with any AI strategy, with any AI application, we need to really focus on the data preparation side of things, and we need to potentially adopt new tools and new frameworks in order to get the right foundations to make our app layer successful. All right, so a couple of observations related to that. When LLM APIs first came out, I think everyone just kind of treated them as an API. It's enough to build the application. And what we've found over the past couple of years is that's not really the case. You do need more of an AI stack, part of that being the data pipeline solution I'll talk about today, but lots of other components to this, right? There's the vector database side with solutions like Milvus. There is the guardrails that we need to mitigate risks and do secure enforcement of access. There's a need to do evaluation and do quality. So a lot of new tools, and especially for enterprises that were not part of the ML ops and search world prior to some of this AI wave, a lot of that was very new. Another big challenge that we saw is that initially we wanted to bring our own context, our own enterprise documents and data to the picture here, but that was challenging without having the right retrieval platform. So at first, folks looked at fine-tuning and other ways to get their context, their data into the language model. But retrieval and the pattern that we'll talk about more today has kind of become a de facto way of bringing that enterprise context. And the proprietary data is really where all the value lives, depending on the use case. But the deeper value for enterprises really requires getting that proprietary context into the application layer. And last point here is evaluation is extremely important in this space and in ML ops and AI applications more broadly. In particular, I really encourage teams to think with an evaluation first mindset. As you think about developing a new application or use case, think about how you're going to evaluate the success of that application right at the outset. So how am I going to construct an evaluation data set? How am I going to monitor retrieval efficacy over time as data changes, as the questions my users are asking changes? This is really important, and it's challenging in this space because we know that models are non-deterministic. We also know that what a good response looks like for some of these applications, that can be very subjective. And so even getting good labeled data consistently from different labelers can be a challenge. So this is kind of a new world to engage in, and we'll talk about evaluation more in the second demo in particular. All right, so retrieval augmented generation is the pattern we're going to talk about today. It's really a way to ground the LLMs in context that we have throughout the enterprise. The challenge is, how do we get that context, that grounded truth to the application layer, to the model, in the right form, at the right time, and how do we make it useful? The disruption that we really see in the data integration market is around unstructured data. You know, when Tim and I were at Hortonworks, we were talking about the value of unstructured data at that time, and that was 8 or 9 years ago now, I think. But we never really got where we needed to be in terms of unlocking the value of unstructured information, multimodal information, things like documents and audio and images. I think one of the most profound paradigm shifts that we're seeing with AI today is that we're now able to compute on language, compute on images and documents, just as we were able to do computation on numbers in the past. And so part of that, of course, is the embeddings themselves, which represent these things as numbers in a sense, in some high dimensional space. But this is something that traditional data tools really struggle to cope with, especially at scale. And the day two moment, after we've kind of found the value in day one, we've refined our use cases, that day two moment is all about scale. It's all about resiliency. It's building pipelines and deployment architectures that are going to be robust and resilient over time. And that's really what Datavalo was founded to do. We are powered by an open source platform that Tim mentioned, which is Apache NiFi, and we'll talk more about that. But let me situate Datavalo in the overall AI stack here. So everything you see in this purple box here, by the way, I like that the Zillis and Datavalo branding and colors seem to be very nicely aligned these days, which is excellent. But everything in that purple box, that's really what Datavalo brings to the table in terms of capabilities. So think about those traditional ETL steps of acquiring data, transforming data, and loading it into vector databases like Zillis, as well as other retrieval platforms, which can include traditional search like Elasticsearch, can include document stores. There's a lot of patterns which are going to use more hybrid search patterns. You might be filtering on metadata, but you might also be fusing results both from a search platform as well as a dense retrieval platform like Milvus. The other aspect of this is orchestration of these pipelines. So how can we schedule them? How can we backfill data? How can we handle when upstream systems might be offline and we need to retry and backfill some data? Or maybe we have a high volume of changes to process and we need to manage that effectively, and that can include back pressure and other key pipeline orchestration capabilities. And then the last piece of this is around observability. We at Datavalo have the philosophy of observability being built in. This should be part and parcel of the platform itself. without my having to add another component to be able to see what's going on with my pipelines. And we think about evaluation and retrieval efficacy as just another lens on pipeline health. And so observing that, monitoring that over time is going to be important as well. So where Datavolo's job ends is really once we've loaded a vector store like Milvus. So we focus on the data engineer persona. We focus on the data engineering required to get the data and make it useful for the AI application layer. We don't focus on the application front-end side. So we're not in the path of the LM or in the path of retrieval. Once the pipeline has done its job, that part of the problem is solved, and that's where Datavolo's job largely ends. I have seen a bit of an anti-pattern with some of the frameworks out there where they seem to conflate some of the data challenges and the data loading aspects with more of that application UX and prompt engineering. And we've firmly believed that to make retrieval work well, you really have to situate that in the data landscape. You have to situate that as a problem to be solved by data engineers. And you really need this clean separation between the application side and the data side. And I think we saw that with prior waves of ML, by the way. It was really the provenance of the data engineer as a skill set and as a persona. And that emerged because, data scientists, ML engineers, they're very good at building predictive models, get good results. They're focusing on the training and the evaluation and strong prediction. Some of the feature engineering and some of the data work that's required, that is more in the wheelhouse of the data engineering team. And we think that same pattern repeats now in the LLM space. And that's why we're really focused on solving for the data part of the problem. All right, so how do we enable the 10x data engineer? Well, as Tim mentioned, we are built on an open source platform called Apache NiFi. This is a proven platform at scale. It's deployed at over 8,000 enterprises worldwide in many areas of high security posture and regulation, like financial services, defense, healthcare, telco. And so meeting that enterprise readiness bar around security and scale is something that NiFi has been doing for a decade or so. We really promote optionality and kind of that Unix mindset of composing tools together. We do not want to be a black box. We want to be pluggable, to have good implementations of different parts of the ETL stack for AI, but to allow folks to plug in their own models, their own transformations, and really promote flexibility and agnosticism throughout the ecosystem. We've created a ton of integrations into that ecosystem, and we'll see more of that in the demo. And then observability, security, really table stakes. It's just built in, it just works, and it's easy to implement and configure. So what have we been doing at Datavalo? We got started late last year, and there's been three major elements that we focused on. So the first is our cloud native form factors. So we deploy both as a SaaS as well as a bring your own cloud model. I think this is pretty similar to the Zillis deployment form factors as well. So you can go with a full serverless type of option, or you can also deploy our platform inside of your cloud VPC. And we also can deploy natively in platforms like Snowflake. And we do provide a Docker-based distribution for folks that might want to deploy Datavalo in their data center. Another big aspect is how we've made security easier. Security is often a challenge to get right. The most secure system is the one that no one can access in some way. And so you have to really balance the trade-offs. And we strive for having the best security posture, but also making it easy for users to implement and configure. And a lot of the managed offering makes that even far simpler and easier. And then, as I mentioned, we've been working hard on the needs of AI systems. So this includes the right integrations to acquire data, the right transformations to make that data useful using machine learning models and different ways to transform data, like chunking and embedding it so we can do good retrieval and search, and we'll see that in the demo. And then the ability to load the right data into the right systems. So we're very excited about the Milvus integrations that we've released. We have integrations into the broader ecosystem. So whether that's evaluation and frameworks like Arise and Galileo, whether that's security and frameworks like Daxa and Peblo, we have partnered with a lot of the key players in the AI stack to have maintainable and easy to use out of the box integrations. And I'll just touch on that maintainability piece quickly. So it's very easy to get started in a lot of these AI applications, again, in that day one setting. But when we go to actually implement these things in production, we're going to see a lot of changes and a lot of churn in a lot of these frameworks and APIs. OpenAI, Anthropic, Google, LangChain, Llama Index, they're all moving extremely quickly. There isn't a lot of stability in these libraries. And so when we build an integration, we are also taking on that burden of maintaining it over time and providing the right version control and the right deployment strategies to adopt it easily. So that's an important point to think about when you think about why I would use Datavalo. We are taking on a lot of the burden of maintaining these integrations, of securing them, things that your team doesn't have to do as far as undifferentiated code. All right, maybe last slide here, and then we will jump into the demo. So I just wanted to highlight as well, Datavalo is a streaming platform. It's a continuous and automated platform. So with one of the things that we've noticed in retrieval is how important the metadata is. So metadata is used for filtering by dimensions before I do semantic search against the embeddings. The metadata can also be used for ranking results, right? Getting the results ranked in the right order is important before I send it to the LLM for generation. And I might also use the metadata for authorization and secure enforcement of retrieval. You know, Sam and Tim, we might not be part of the same team within an organization, and we might not be entitled to get the same answers from a chatbot because we have different privileges, different access to the underlying source documents. And so we talk about CDC or change data capture for unstructured data because we're able to ingest change in an event-driven way from different upstream systems, let's say Google Drive or SharePoint, and then propagate those changes downstream. So for access control, that's extremely important. If Tim's access on a document changes, we'd want to know that right away. We'd want to replicate that change down to the vector database so that that updated metadata can be used for enforcement. All right. With that, let's jump into the demo. We can talk more about the platform partnerships and, of course, our ecosystem integrations, Zillis being a highlight for today. All right, I'm going to jump over to the Datavalo UI. So as I described at the outset, this demo is really to acquire financial 10Ks from some different companies like NVIDIA and Apple, and to parse them, chunk them, embed them, and store them so that we can build a chatbot, chat with your data experience. Imagine I'm a financial analyst type of persona that wants to very quickly and easily get the right insights out of these multi-hundred-page documents. And as we'll see, these documents have complex elements in them. They have tables, they have sections, they don't have markup. So unlike something like an HTML document or a Markdown document where we can split things by that markup, we don't have that in a PDF. So we actually have to derive that markup, derive that metadata to figure out how to chunk in the right ways. And of course, with RAG, you're always striking this balance of how to best split the data so I can get good retrieval efficacy and also good generation from the language model. All right, so how do we acquire the documents? We have over 350 integrations that ship out of the box. I'm showing S3 today, but you can imagine this being a host of different systems. You know, if we think about some of those Google Drive changes I mentioned, we can capture those in an event-driven way, or maybe we want to do that for SharePoint. Really, so many systems that we could talk about here, but Any of the major enterprise platforms that you can think of, we have a built-in integration. This platform is also extensible, so you can build your own. But in this case, all of our documents are in S3, and we're going to acquire them from there. Very easy to configure a integration like this in Datavalo. I'm just specifying what S3 bucket to use. I'm going to use a service to provide my authentication so I can access those. One thing I'll call out here is the listing strategy. So I mentioned Datavalo is continuous and automated. So as new data arrives in that S3 bucket, we're going to pull it into this flow right away. So if we have a process that is landing those documents, we will get them in near real time. But maybe we don't want to reprocess older documents. And so I'm using this timestamp strategy to only acquire things I haven't seen before. And we're going to store a little bit of state to do that. And this is pretty useful to make sure I'm only processing new things. And there's different strategies for this. I can also use hashing techniques and track this at the entity level. But this looks good. I'm going to, after I list the data, I'm going to fetch the data. And we do this in two different pieces because this makes it really scalable. We run on Kubernetes. So this environment we're seeing here is in EKS in our SaaS environment. And we're going to scale horizontally with volume. So we have a pattern here where the listing might just run on one node, and then it's going to split out that metadata listing across many nodes so that they can all fetch data in parallel and not step on one another. We also capture provenance. So this entire directed graph that we see within Datavalo, every state change between processors here is going to be captured as a provenance event. So in particular, when I fetched the raw data, I can look at the output here. And so we have this NVIDIA PDF. This is a 100-page 10K with lots of complex information. If we scroll down into the document, we're going to have things like tables. We need to be very careful about how we parse these tables. We don't want to split this in half and kind of ruin the referential integrity of that. We're also going to have charts and images, and these are going to be important as well. And so we'll see how we parse this data in a moment. All right, so I'm going to clean up a few things, set some URLs and doc types. The data engineer can set different metadata on this event, which is really useful. We're going to see metadata as a theme throughout this demo, but just to show you what this looks like in the attributes. So we've automatically generated some metadata, and others were captured by the data engineer. We're going to bundle up all of that metadata before we write the data to Milvus. And that's going to enable some of those hybrid search use cases and ranking search cases I described. So you can see some of this was grabbed from S3. And then we have things like the original source URL. When we're doing a RAG app, we really want to be able to do citations. And that's part of this grounding aspect, right? So when I return a chunk, I might want to return it with that original source URL. And I can even get more specific than that with sections, which we'll see in the demo in a moment. All right, so after I have that raw PDF, I'm now going to do some computer vision to do what's called layout detection. So layout detection is going to give me bounding boxes and labels of every component of the document. And we have in our environment here, we have a model. We have fine-tuned it and customized it. It's based on some prior art with a model called YOLO-X. But this is running on a GPU in a shared service, and we use this to derive those bounding boxes and labels. We can also do OCR if we need to extract text if it's not in a text layer. But importantly, we're going to use those labels, and let me show you actually an example of what this looks like. So we have this PDF annotation viewer in the UI. And so this looks similar to what we were just looking at, except now you can see I have all these boxes and labels around all the different components of the document. So if we go down to some of those more complex elements, we see things like tables. If I click it, you'll notice that on the left-hand side, I've actually built this hierarchy. This hierarchy is really useful because when I'm traversing the document, I want to use this as a document graph, essentially. I want to be able to pull the siblings. For instance, this table is going to have narrative text above it that's describing what's happening in the table. Similarly with the image. So I want to be able to pull the preceding and succeeding chunks that surround an element like this. I'm also going to want to chunk this document by the sections. So you'll notice that in the green text here, we've recognized this as a section with high confidence. And this hierarchy is collapsible on the left-hand side. So all these different narrative text elements are tied to this section. So sometimes I might want to match on some narrative text, but pull a bigger chunk like the full section into the prompt that I send to the LM to generate the response. You're always playing this game of RAG, this Goldilocks game of I want to have the right semantic precision in the embedding to get good matches against my queries, but I also want to have good richness for generation and give as much context to the model as possible. And those two actually push and pull on one another, so you have to decide how to balance that trade-off. Similarly for images, and this gets pretty interesting, you also want to have something that you can embed and retrieve about this image. Now you could use multimodal embeddings to actually embed the image itself, and there's some really exciting work around vision language models. Tim and I have been talking about that from a Zillis support standpoint in terms of some of these multi-vector representations that you need for these VLM models, these late interaction retrieval models. But in addition to embedding the image in that kind of multimodal embedding, something like CLIP, we can also use language models to describe the image. So the language model is going to give us natural language back. We can embed and retrieve that natural language, and then we can also use this graph, this hierarchy, to pull related chunks based on where they sit in a document. So this table is related to this image, this preceding description is related to it as well. And so all of that is available to us in the parsed format that we're going to land in the Milvus database. Excellent. All right. And you'll notice that we use LLMs during the pre-processing stage. So we might use that to describe an image or to summarize some text. So when I said we weren't in the path of the LLM, maybe I lied a little bit. We're not in the path of the LLM during the user interaction, during the query time or retrieval time, but we often do use LLMs in the ETL process or the data pipeline to make the data useful before landing it within the vector database. All right, let's go back to our main flow. So one cool thing here is we can use those derived annotations about each component of the document to route it to different downstream parsers. So I'm routing the images and the tables in particular to different downstream models. For the image, which comes in here, as we just talked about, we're going to use GPT-4o Mini. You can be very dynamic, by the way, with model selection and model routing using Datavalo. This is becoming increasingly important because some models are big and give high quality responses. Other models are smaller, give maybe slightly lower quality, but faster, cheaper responses. And so as a data engineer, I might want to balance fast and cheap versus quality. And in some cases, these smaller models do quite well. We're even seeing some true SLMs, small language models with 1 billion parameters or under. Yes, that does sound large, but compared to multi-hundred billion parameter models, they are much more svelte. But we're seeing some SLMs used for evaluation in particular. I mentioned Galileo, so they've created one that is very low latency so that you can use it in the path without creating a lot of delay. So we're using GPT-4o Mini here. We have a system prompt to help us describe this image, and we're going to get some natural language back that we can then retrieve and embed. On the table side, just like that layout detection model, we've also developed our own proprietary table extraction model. It's actually a table transformer model. It again is based on prior art, but we've customized this and tuned this. There are big data sets out there like DocLayNet, which have a lot of table examples in complex PDFs. And so we've used those publicly available data sets to really make the extraction better. So the output of this model, and again, this is pointing to an ML service running under the hood on a GPU in our SaaS environment. This is going to give us a CSV style representation of the rows and columns with the right data types extracted from each cell. We can load that into a variant table in a database. We can parse it and extract it. We can also just describe what's in it, again, using a language model. And you might not need to do this step. You might want to skip it because it might be more tokens that you're sending out to OpenAI and leading to cost. But we have found it's nice to also describe the CSV output of the table image extractor and use that as something we can retrieve and search as well. Finally, at the end of this step, or at the end of this subflow, we're going to merge everything back together. So remember, we split things apart. We split apart the tables and the images and the text. We're then going to merge it back together. Behind the scenes, we're going to have, if I go into the data provenance here, what this looks like. It looks nicer in that PDF viewer, but just for kicks here, this is the underlying JSON representation of that parsed information. And so this is what we're going to use downstream to do chunking, to do embedding. And if you want to drop into this lower level representation, you can do that as well. All right, so we've now merged everything back together. We are going to come back to our main flow. One thing we do want to do sometimes during pre-processing is we want to do enrichment. So if you, again, have that evaluation first mindset and you're thinking about how are users going to query this data, they often are going to ask questions that are, let's say we're dealing with an NVIDIA 10K, they're going to ask questions about NVIDIA as a company that might not be contained in the 10K. So they're going to ask questions like, well, how many employees does NVIDIA have? Or where is the headquarters? Or maybe I want to trend things over multiple documents. So you often need to do some entity recognition and some enrichment with those recognized entities to get even more context into your parsed document. So in this case, we are extracting the ticker like NVDA, and we're using that to do a lookup. We have a Postgres table here that has some more information about some of the companies we care about. That's going to pull in that additional company level data. But you can think about this as enriching any entity, right? Any knowledge base you have or data warehouse that contains information about that entity, you might want to bring that into your retrieval system here to answer more user questions than you could if you were just using the document. And so that's what the enrichment step is all about. I'm going to skip down here to chunking. I do want to, if we have time, briefly cover evaluation as well. So I'll drill into this chunking subflow. So we're going to chunk in a few different passes here. The first pass is going to use chunk document, which expects that JSON representation. And we're going to chunk by section. So there's a few different strategies I could choose here, but section is really nice because it's going to have that nice balance of semantic precision. It's just talking about a few things, but it also has good richness. And we've derived the section labels with that layout detection model, and we're going to use them as our chunking boundaries. And we're also, because we're using those as boundaries, we're going to not run into any challenges with chunking those tables or images. They're going to be split out separately. And we can tune certain things. Maybe we do or don't want to include subsections. Maybe we want to tune these chunk sizes or overlaps, which are useful. You essentially have a bunch of hyperparameters, and as a data engineer, I'm tweaking them to get the best retrieval results so that my AI engineer has the best data set to work with. But this does tie into evaluation as well. I want to be able to capture which hyperparameters, which chunking strategies, parsing strategies lead to the best retrieval outcomes. And so you can capture each of these hyperparameters in line with your evaluation metrics and essentially do some data science to correlate between those hyperparameter values and the best possible retrieval scores. And we can definitely chat more about that. All right, so now we've chunked by section, but I'm going to do one final chunking pass. So I also, once I have section text, I can also chunk that text further. And again, this might be useful because I want to kind of play with that precision and richness trade-off. So the most naive thing I can do, and it doesn't really work that well, but just to show you different examples, is to chunk by 400 characters at a time. So this is just going to use 400 characters. It will run into problems with, maybe splitting something that's semantically connected in the middle. It has no notion of like what is a sentence boundary or what is a semantic boundary, so it generally doesn't work that well. But I also have this chunk text processor, and the reason I'm splitting this all out is to do proper evaluation. So I'm doing it in parallel, which is nice, and I'm storing different collections in Milvus so that I can point my evaluation data set at those different collections and see which performs the best. So another option I have is semantic chunking. We also have things like sentence-based recursive delimiters. With semantic chunking, I can tune, again, things like the similarity threshold. This is computing cosine similarity between pairs of consecutive sentences. So we look for that sentence break, but then we compare cosine similarity, and we only call it a split if we drop below this threshold. And so we've tuned it. How did we arrive at 0.6? Well, like with many things in machine learning, we just empirically tried different things and we decided what worked best based on evaluation. So very common in machine learning to get these kind of magic numbers for your hyperparameter values. But we do have another option that we tested, and 0.4 has worked less well. So just something that you can, again, tune and evaluate. All right. So after we have our final chunks, this is the granularity that we're going to persist to our Milvus database. We're using Zillus's serverless environment here. But before I write them to the database, I do want to first create my embeddings. Again, at any part of this flow, I can come in here and see the output. So in this case, we have text, and we also have the embedding weights. But very importantly, I want to capture all of the chunk metadata and write that in line with the embeddings themselves. So the way I've done that is I've organized all of my different metadata paths in one place. And the cool thing to note here is each of these metadata elements, they came from different parts of the pre-processing flow. Some were set automatically by the system, some were derived by those machine learning models, and others were set by the data engineer. So things like the document type and the URL were set by the engineer as part of their flow design. And then we also captured some things via that enrichment part of the process. So things like the title hierarchy, we used the symbol to look up in that Postgres table what this hierarchy was, and we've captured that as a metadata element as well. All right, we're now ready to write this data into Milvus. As I mentioned, we are using the Zillis serverless environment. So we have a connection service here. And if I just show you that briefly, we're coming into this serverless environment, very nice and easy to provision and works very well from a performance standpoint. And then I just have to configure my authentication. We store everything using secrets and integration with secrets managers. So we don't have to worry about our credentials being leaked. And then I'm just configuring things like which collection am I writing to, what are my different paths of where I want to store things, such as the chunk content, the metadata, and we can store the content if we want to do that pattern where we're maybe sending different text to the model during generation. All right, so now we're done with this flow. We've written our data to our vector database. We're ready for the AI engineer to kind of take over here. Before we go to questions, I did want to talk a little bit about evaluation. So let me go to a different environment here. So with this evaluation first mindset, the thing that we want to do first is we want to acquire or build an evaluation data set. So for this one, I'm using a Wikipedia data set here for the example. And there is a known set of questions and answers about these Wikipedia articles that we pulled. I'm just pulling a few here for example, but we pulled Wikipedia articles about some hockey games and hockey players, and some other articles here about Ireland and community activism in Chicago. Very diverse set of Wikipedia articles here. But the key thing is that we have questions and answers that came from our evaluation data set. So one thing we'll often ask is, well, what if I don't have that data set? Well, there's a couple options. The first thing is you might want to use human experts, similar to how you might label data, to build that Q&A data set. You might also have prior historical data that can be used. So for instance, if I'm building like an HR chatbot, well, I would ask myself, how did users get answers from HR in the past? They probably had a ticket that they created, or they sent an email. Can I acquire the history of questions and answers that have been asked in the past and use that to build an evaluation data set? A third option is we can actually use language models to synthetically generate evaluation data sets. So if we have the answers, we can pretend we're playing Jeopardy and we can ask the model for the question, and it will oftentimes do a very good job of giving us questions synthetically that we can use to construct the data set. You probably would use a mix of these techniques in real life, but the important point is you're never going to know how well things are working if you don't acquire, build, synthesize that data set at the outset. So that's very important. So we're going to do some pre-processing with these ground truth questions. And then I'm going to do a bunch of different embeddings here. I'm going to embed the questions. I'm going to embed my ground truth, which is that answer. I'm also going to generate an answer. That's going to be the generated one, and I'm going to embed that too. We're going to need to do some comparison similarity-wise of each of these different aspects. All right, so once I've embedded my questions, I can now query the database. So just like we saw the ingest into Milvus in the previous flow, we also have the ability to query Milvus. And so very similar setup here. What we're going to do here is we're going to take the question. So you can imagine this would be coming from a user if it was deployed to the application layer. But in this case, I'm pulling the question from the eval dataset. I'm going to embed that, and I'm going to do matching of that embedded query against the embedded generated answer. All right, so what do we actually mean by evaluation? And I'm focused here on two classes of evaluation metrics. One are the traditional information retrieval metrics. So these are things like context recall, context precision, mean reciprocal rank, and then the end-to-end metrics, which are based on the response of the language model. So these are things like faithfulness that we'll see in the next part of the flow. All right, so what I now want to do is I want to evaluate how well retrieval has worked, and I'm going to use the LLM as a judge. That's what this pattern is called, rather than asking a human labeler to assess. We're asking the LLM to assess. So we're going to send the question. We're going to send the results. So when I did this query against Milvus, if we look at the output, I got results, right? So if I took that first example, who were the 3 stars in the NHL game between Buffalo Sabres and Edmonton Oilers? We have an answer. We have a ground truth from the Q&A data set. But what I want to do is take the question, and I want to see, based on the data I've loaded into Milvus, I skipped that step for brevity, but we loaded all this data into Milvus as well after chunking it. So I'm seeing the score here, which is cosine similarity between the question and some retrieved chunks that I had stored in the vector database. So we're doing k equals 3 here, just getting 3 results. But those are the results that we get, and that's what I'm passing into this integration to, in this case, we're using GPT-4o mini. So that's the context. And then the ground truth is the answer. And then we're going to persist some retrieval results. So we can take a look at that. So now we have retrieval results. We have things like recall, precision, and then F1 score, which is a blend of recall and precision because they do push and pull on one another. F score is the harmonic mean of recall and precision. And then we can also compute the mean reciprocal rank. What the language model is telling us is whether given statements actually match the provided context. So you can see for a given chunk ID, this one matched, and it gives us a reason. This all came back from the language model. The context explicitly lists those 3 stars. These were the 3 stars, the name, and we have a reason. So we're able to derive these attribution scores. This could have been a human labeler. We're just using an LLM to do this in a more automated way. And so now, because we have those attributions, we can do evaluation properly. The next thing we need to do, so those are all retrieval metrics. We were able to compute recall precision. I can use this to determine how well my parsing and chunking worked from that first demo. But now we want to do the end-to-end part. So what does that mean? We now want to generate answers using the language model from the provided context, right? That's what retrieval augmented generation is all about. So we're going to generate answers, and we're going to compare the answers against the ground truth that I had in my eval data set. All right, so after I've generated answers, embedded the ground truth, embedded the generated answer, I can now evaluate 2 other metrics. The first is answer correctness, and the last one is faithfulness. So answer correctness is going to be a function of the F1 score, and it's going to be related to how well the ground truth compares to the generated answer. So if we take a look at this, we'll get some more interesting output here. And by the way, we can send these results to an experimentation framework. So a lot of folks use MLflow or weights and biases as like an MLOps experiment tracker, and we have integrations into those. But now we have both the retrieval metrics as well as the actual answer correctness evaluation. So we have a generated answer. We did compute the embedding for the generated answer as well as the ground truth. And then we were able to assess answer correctness. We got a very high score here of 96% for on average across the top K results. But clearly the first answer was the best. So we can use this to as feedback into how we're building the data pipeline and determine which strategy is best. But it's nice to have that answer correctness in a single number. And the last one is faithfulness. So believe it or not, these models can still hallucinate, even if you give them all the beautiful context in the right reading order. They can still decide to generate something else. And faithfulness is a measure of that. So faithfulness, it extracts the claims, so like statements of fact from the retrieved chunks, and it computes to what percentage that retrieved context was used to answer the question. So if we take a final look at this step, we're going to see that for faithfulness, we evaluated this as well, and we got a good score here. So the model is using the retrieved context to answer the question. It didn't add any additional noise to the answer. And then finally, we can record these metrics. So MLflow is one of the integrations. We're using our Databricks environment here to integrate into MLflow. And then I can have different experiments that I track over time and tie those back to the hyperparameter values. All right, so hopefully that was fun and exciting. Let's pause here and go to some audience questions.
Okay, let me see what we got here. Checking the Q&A in the chat. Okay, put one from QA down in the chat and I'll read it for you. Why is a new kind of ETL platform needed to make AI apps successful?
Great question. Thank you, Tim. And this really goes to the heart of why Datavalo exists as a company. So love the question here. So I think the first thing we saw is disruption in the ETL market relative to unstructured data. So a lot of systems, they're really built to replicate relational data from a database to a data warehouse. And they have more of that ELT pattern where I do transformation after I land the data. That really is not the case with embeddings. And I think embeddings are going to be one of the important residues of this AI wave. We're going to recognize them more as a first-class data citizen. And one thing you'll find with embeddings is you can't really transform them after the fact. You can't really do this ELT pattern. You have to do the transformation, including the metadata acquisition in the pre-processing layer. And so Datavalo is built for that. First of all, the underlying technology NiFi is built to handle any form of data, really any byte stream, audio, video, images, text, and to do that in a very scalable way. But also the last part of this is we also have to make the data useful before we land it. And that's where we've invested in these ML-powered models to better extract and parse the right information. So if I'm dealing with complex PDFs, I need to be able to do that section metadata derivation so I can chunk the data correctly. I need to recognize tables and extract the tabular data correctly. Those are the sort of investments you would want in an ETL platform designed for multimodal data.
Makes sense. Let me check for another one. Yeah, I've done some pretty cool flows with NiFi and unstructured data. It's pretty awesome. Okay, we got another one. Why are continuous and automated data pipelines important for AI apps?
Excellent. And I also see one from Vincent. I'll answer
Oh,
the one you just posed first, Tim, and then we can go to Vincent's questions. So yes, so continuous and automated is really important. And you have to think about this not just for the content of the data, but also the metadata. So metadata of documents is going to change over time. Permissions can be added and deleted. We might create new versions of these. And once you're building these retrieval platforms, they're going to become one of the de facto interfaces for your teams to access all of your data. And so once that's happening, you need to keep these retrieval stores up to date as the state of the world changes. You don't want stale data. We've all noticed with like GPT models that based on their training cutoff, they don't know what's happened over the past 2 months, 3 months. Another good use case for RAG or search in concert with the language model. But you have to have these continuous and automated pipelines to keep both the content and the context up to date at all times so that users are getting fresh answers from the AI application.
okay, very good. You might as well do Vincent's. He's got a
Excellent.
in there.
Thank you, Vincent. So great question. So let me talk about LangChain, then I'll talk about LangGraph specifically. So if we go back to that diagram I showed where we have the Datavalo situated in the AI stack, I'll just pull that up briefly. I put LangChain more broadly on the right-hand side in that application framework setting. So LangChain is really good at the application UX, at prompt engineering, at having the right templates. But where we believe that it's kind of conflating some of the overall problem here is the data loading and the data engineering. We think that should be situated more in a true data pipeline solution. So we believe that LangChain should focus on that application side, the front end side, and use a real data pipeline solution for loading the data into the right platforms and doing the transformation. This is especially important at scale when it's not about just doing this for one document, but it's about doing it for all my documents and doing that in a continuous way. Now, LangGraph specifically is very interesting. It's more, in my understanding, about agents and orchestrating different agents and building these cognitive architectures that Harrison likes to talk about. So I think that's a very important area. We're actually using agents for our Copilot service, which you'll see released soon. And this Copilot is intended to help data engineers build the right pipelines. As Tim has probably experienced, jolt transforms can be annoying. Getting a connection string right, getting a regular expression right. Wouldn't it be nice to just ask a Copilot how I should configure this processor and it'll just do it for me? Absolutely it would, and we've worked hard on building a nice alpha version of that, so you'll see that soon. But I would think about LangGraph as more building that overall agentic architecture, which is situated in that front end, and Datavalo is more about solving for the data pipeline side of things. It's not in the path of the user sending a task or a prompt to an agent.
Okay, there was a question about the recording. It will be emailed to you if you're registered. If not, it will be in YouTube under Zilla's, and I'm sure Datavolo will have a link to it. You'll be easily able to find it, and we'll make sure the slides are out there as well. We got another question. What are you seeing as some of the major blockers for enterprises to adopt AI, which we've all seen these?
Yes, this is something we think hard about every day. I think we all got very excited around the ChatGPT moment of the promise of this technology, and the promise is fully real. I think this is one of the biggest paradigm shifts I've seen in my career, along with cloud and big data and mobile. But enterprises right now, they are seeing a few challenges in adoption. One of the big ones is the risks that are associated with not doing things in the right way. So I talked about having the proper guardrails. That can include role-based access and secure enforcement at retrieval time. That can include having the right evaluation and testing. And one problem is that user expectations have to be set appropriately. One thing that really helps evaluation is publishing your application as soon as you possibly can, even when you're still embarrassed about how well it's working. And the reason for that is you're going to start this flywheel where users are going to give you feedback on good and bad responses, right? Thumbs up, thumbs down. Every time you see a thumbs down, that's gold for improving your application and the overall stack. So I encourage folks to start acquiring that user feedback in an automated, scaled way so that you can use that to improve the application. Setting the right expectations, having the right guardrails. I think also enterprises, they did not necessarily build out that full stack with the best of breed solutions. So a lot of folks are constrained by wanting to do things not using certain cloud services. Maybe they don't want to use OpenAI or Anthropic. So maybe they're using underpowered models. The open source models are super exciting, but Llama 3.1, maybe when you start to get into 400 billion, it gets a little bit better, but Llama 3.1 versus something like Claude 3.5 or GPT 4.0 is a big difference in performance, like several orders of magnitude, I would say. So you have to pick the right technology and build the right stack. And some folks have been constrained, whether it's about risk or trust or guardrails, to use some of the best models and the best architectures. And so that's something where I've also seen an adoption challenge.
Okay, we got time for one last question, and I see it down there from Pravin. How do you think role-based accessed embedding in these? How do you think role-based accessed embedding in these AI models?
I think I get the drift, Pravin. So I think this is about the secure enforcement where we're talking about different users with different entitlements. They should get different results when they go to ask a question and get retrieved context. So we do that using metadata. So we don't actually change the embedding itself, but when you store the vector, you also store the metadata around which groups and users had access to this document. And then you have to implement secure retrieval in your retriever in your application. Daxa, by the way, is a partner that we've worked with that does this. It's an open source framework under the hood called Peblo. But the secure retriever is going to acquire the user's groups and context based on the authentication event to the application. And it's going to match those group memberships and entitlements against that metadata that we've stored. And it's only going to return retrieved results that match the right permissions of that user. And then only at that time does it do semantic search against those embeddings. So it's a hybrid search model. You trust the application to acquire the right authorization rules associated with the user's authentication context, and you match that against the metadata. You'll see metadata as like a really important aspect of this throughout the application side. I tried to emphasize it a lot because it is really important both for hybrid search, re-ranking, and secure access.
Very cool. I think we're out of time and they're going to shut us down. So thanks from your team there. Say hi to Joe. And thank you for everyone attending. You will get the slides. You will get this video. Maybe we'll clean it up and make us look magically better. I'll have a better jacket. Thanks again, and we'll see you probably next week. Thanks a lot, everyone.
Thank you very much, Tim. Thanks for having us, and thank you to our audience.
Thanks, everyone.